Okay, so this is the first generator problem or question. And the first one, first part A, asks draw the magnet in a position that creates maximum magnetic flux in the coil. Remember, magnetic flux is proportional to the strength of the magnetic field. You can think about it like kind of like the number of magnetic field lines that are present through the coil. And so what we would want is to have the north or south pole of the magnet as close as it can be to the coil, which means that if you're looking at the field lines do something like this. Okay, and so plenty of them are present in the coil, where fewer of them are present in the coil in the black outline position where it was originally. Okay, so that's what you're looking for there, and on to the next part. Okay, so why must the magnet be continuously rotated to produce electrical energy? Well, remember that Faraday's law, and maybe I'll use a different color here. Faraday's law tells us that the most important part being there must be a changing magnetic flux, okay, rate change of magnetic flux, to induce some amount of voltage on the coils, okay? So if you weren't continuously rotating it, right, if you just kind of like gave it a little spin and then let it coast to a stop, you would temporarily be changing the magnetic flux because this thing would be rotating here. And so you, at this point, right, if you sort of imagine it in this position, you'd be reducing the magnetic flux, and then it comes back around and increases the magnetic flux. And so a continuous rotation is required to have a continuously changing magnetic flux. Okay? And that means that if you have a continuously changing magnetic flux, then you will have an induced voltage all the time. Okay? And in the case of a rotational, machine like this, you'd have voltage induced per unit time on those coils that looked like a sine wave. Okay. All right, so what's the last bit? The last bit says, would this generator produce AC or DC? Well, we kind of just answered that, but to get DC out of a generator, you need to do one of a couple of things. Either you can use an assembly called a commutator brush assembly, which would sort of flip-flop the connections essentially to the exterior, so you'd always have the same polarity of voltage, and so you'd get something that looks like this. Boom, 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 like that. All right. And if you do some more modifications, you can make it look flatter and things like that. But we didn't really talk about that mechanical means in class. What we talked about is attaching a rectifier, that series of diodes, essentially, to the output of the generator. But we don't see that here. And so we know that by default, AC is the thing that it would produce. Okay? Essentially by default, because of the rotational motion and how the magnetic flux is changing per time. Okay, that's the end of that one. Nice and simple, short and sweet. See you for the next one.